Explain the meaning of the slope of position versus time graphs, part 2. Velocity. Let's figure out what this means in physics class. Well, you guys know that the slope of a position versus time graph is the velocity, rise divided by run, on those types of graphs. And velocity is how fast you are moving as well as the direction. So we specify a direction with velocity. The sign of the velocity tells you the direction. Is the velocity positive or is the velocity negative? And that tells you whether he's going left or right. And the symbol for velocity is v. This is all straightforward stuff, people. Velocity is very similar to speed, but speed does not specify a direction. For example, when we say I'm driving 45 miles per hour, that doesn't tell us whether we're going left or right or up or down. It does not specify a direction. We call this type of variable a vector variable. A vector variable. Now, that was kind of confusing. I'm going to cross this out here. When we say this type, I mean the velocity type, not the speed type. Velocity, not speed. So velocity variable is a vector variable. Speed is a scalar variable, which we'll talk about what that is sometime in the future. We can show the amount of velocity and the direction with an arrow. We can show the velocity and the amount with an arrow. So if we look at this guy who's running to the left, hey, I missed my bus. I gotta run. He's running, but he's not going that fast. Like, look at that form. That's bad form. So I'm gonna say that he's going to the left. Oh my gosh, let me get a little bit different pen here. So he's going this way. One more time. One more time. I'm gonna write velocity with a V, and I'm gonna give him a little arrow going that way to the left. Now, oh my gosh, the Flash! Flash goes super fast. So I'm going to make his velocity vector. I'm going to write a little v here, but I'm going to draw his arrow a lot longer to specify the amount. And often you can see like a little sign like negative, and you could put another one that maybe he is going the positive direction. So right is the positive direction and left is the negative direction. So velocity is a vector. Similarly to how your car measures velocity in miles per hour or speed in miles per hour, in physics class we use meters per second. We use meters per second, or m/s as the units. Okay, let's get into it. You may have heard that velocity equals distance over time, and that's correct. So here's our equation here. V equals d over t, where v is velocity, d is distance, and t is time. Distance is really the same thing as your change in position. I don't know why it says your. It should say as change in position. So another way to think about this velocity equation is that velocity is change in position divided by the change in time. So we have change in position divided by the change in time. We can rewrite the equation v equals change in position divided by the change in time. It's just another way to rewrite this equation with just a different word for distance. Your distance is whatever your change in position is. I was at 0 meters, now I'm at 6 meters. My change in position, I've gone a distance of 6 meters. And it took me 6 seconds, so that's my change in time. Easy peasy lemon squeezy. Let's fill out this table here. So velocity, the symbol is v. The units are meters per second. The time is another variable that we use in this class. The symbol for time is a lowercase t, and the units are seconds. And for position, the units are meters. Easy enough. Easy enough. Just make sure you remember all this stuff. Slope of position versus time graphs. Okay, we talked about this in the last video, but here we have it. How exactly does the slope of a position versus time graph show velocity? I'm talking really slowly right now because this section here, I promise you guys, you'll need to memorize this stream of logic. If I were you, I would memorize this stream of logic, or this chain of logic. I don't know what the right way to say that is. But this is how you can be exactly precise with your language. So if someone said, what is the meaning of the slope of a position versus time graph? I want you to start thinking in these terms. Well, the definition of slope is rise over run. The rise, or the change in y on a PV graph, is the rise. So here's my y axes, and the rise here, we'll use this point. The rise is the change in position. The rise tells you the change in position. You can see that I started at 0 and ended at 50. So the rise of the graph is the change in position. Is the change in position. Makes sense? And when I say the rise is this, I'm talking about the variable on the axis. And the run, or the change in the x-axis, is the change in time. So let's look at this before I write it. So the run, so here's my run. It's the meaning of the run is I started at 0 seconds, I ended at 5 seconds, so the run is the change in time. Change in time. So let's put it together. So therefore is a great word to use whenever you're saying because of this, that. I gave you one piece of evidence, and what does that mean? Therefore, rise divided by run on this graph is equivalent to change in position divided by change in time. Change in position divided by change in time. Rise divided by run, rise divided by run. So now we're setting these all these ideas equivalent or equal to each other. The rise divided by the run on a position versus time graph is the same as the change in position divided by the change in time, which equals velocity. Okay? I bet some of you guys are saying, okay, yeah, obvious. But the reason why I'm going slow is because I want you guys to be able to say this. I want you guys to be able to say this. If I say, hey, can you tell me what's the slope of a position versus time graph? Oh, well, you know, this definition of slope is rise divided by run, and the rise on a Pvt graph is the change in position, and the run is the change in time. Therefore, the rise divided by run on a graph is equivalent to the change in position divided by the change in time, which is velocity. Oh my gosh. If you can say that, you're going to pass this class with flying colors. And if your parents heard you talking about, the change in position divided by the change in time equals velocity, they're going to think you're some super genius, because think about the words that have just come out of your mouth. It's amazing. You guys are thinking and speaking like scientists. Also note that the units of the slope is meters per second. Also note that the units of the slope is meters per second, which are the units of velocity. We just wrote it there. Boom. So there's a couple ways that you could explain why the slope of a Pvt graph is velocity. Here's a quick extra note. Sometimes you'll see a position versus time graph, and it'll be shown with an X label, with the label X versus T. This X does not refer to the x-axis, but rather the horizontal position. What? Writing X on the y-axis? Yep, you heard it first here, people. The position is still graphed on the y-axis. It's still graphed. So you see how this graph here, let's zoom out for a second. You see how this graph has an X here? Why the heck are they writing X on the y-axis? That's because in this context, this X does not mean x-axis. This X means horizontal position. So here's our soccer ball. It's rolling this way. It's got a positive velocity, and its position, it's saying X. It's using the letter X to denote where it is horizontally. So Here it's at position 0, here's at, I don't know, position 1. Makes sense, okay? But it is a little confusing. Physics sometimes makes things really annoying by using the same symbol for two different variables or two concepts. It's not something that you haven't seen already. For example, this m, does that mean slope or does that mean meters? Well, it means meters. It's in parentheses. These are the units for position. This is not the m that's the y equals mx plus b in slope. We just only have 26 letters in the alphabet, so we have to double up on some of these, which is why context is important. Context is important. So you got to know when your x means the x-axis and when your x means horizontal position. And lastly, other times you may see a position versus time graph with the label y versus t. This just means that the position is being graphed in the up and down direction, or the vertical. Oh my gosh, why did I say up and down? I meant to say vertical. The vertical direction, and this will be for objects moving vertically, like a rocket launch or a ball being dropped. So, you got your ball, it's dropping, and this is your y1, and this is your y2, and so it is. So we have a change in y. That does not mean the y-axis. This is, in this context, this does not mean rise. This means your change in vertical position, okay? Don't be confused, my friends. All will be well.